Notations for partial derivatives. If z is equals to function of xy, we write fx of xy or fx or partial f over partial x or partial over partial x of f of xy or partial z over partial x if we differentiate z with respect to x, and fy of xy or fy or partial f over partial y or partial over partial y f of xy or partial z over partial y if we differentiate z with respect to y. Rule for finding partial derivatives of z f of xy. So number one, to find fx, regard y as a constant and differentiate f of xy with respect to x. And number two, to find fy, regard x as a constant and differentiate f with respect to y. Example number one, if f of xy is equals to x cube plus x square y cube minus 2y square, find fx at 2, 1 and fy at 2, 1. So if we want to find partial f over partial x, we hold y as constant and differentiate with respect to x. So x cube 3x square plus power down and power minus 1 2x y cube, as y is considered as constant, so this will be 0. Now replace in this x 2 and y is equals to 1 and we'll get 16. Now we have to find partial f over partial y or fy at 2, 1. So we consider x as constant and differentiate with respect to y. So x is constant, so this is 0. This is coefficient x square as it is, power down and power minus 1, 3y square minus 2 times 2, 4, power down, power minus 1, 4y. Now replace here x as 2 and y as 1 and simplify it, we'll get 8. Example, find the second partial derivatives of f is equals to x cube plus x square y cube minus 2y square. To find second order partial derivatives, first we have to find the first order. So fx means differentiate f with respect to x. 3x square plus power down 2x y cube minus, consider y as constant, so this is 0. Now differentiate f with respect to y. X cube is constant, so this is 0. Power down 3 y square x square minus 2 times 2 4 y. Now we will find second order derivatives. fxy means differentiate fx with respect to y. So this is 0, 6xy square. fyx means differentiate fy with respect to x. 2 times 3 x y square. Y is constant, so 0. fxx means differentiate fx with respect to x and consider y as a constant. So 2 times 3, 6x plus derivative of x is 1, 2y cube. fyy means differentiate fy with respect to y. So partial over partial y, 3x square y square minus 4y will get 2 times 3, 6y x square as it is minus 4. the chain rule. Suppose that z is a function of xy and x is a function of t, y is a function of t, and both are differentiable. Then dz over dt is equals to partial f over partial x into dx over dt plus partial f over partial y into dy over dt. Example number 1. If z is equals to x square y plus 3xy4, where x is equals to sine 2t and y is equals to cos t, find dz over dt when t is 0. Solution. We will apply this chain rule. So partial z over partial x will get 2xy plus 3y4. Consider y as constant when you differentiate z. Dx over dt will get 2 cos 2t. Partial z over partial y, differentiate z with respect to y and consider x as constant. We'll get x squared plus 12xy cube. Dy over dt is equals to minus sine t. Put all these values in the formula and we'll get this. Now we want to find dz over dt when t is 0. When we put t as 0, we'll get x is equals to 0. And when we put t as 0 here, we'll get y is equals to 1. So x is 0, y is equals to 1, and t is equals to 0. Put all the values in this equation and we'll get our final answer as 6 after simplification.
Example, if u is equal to x4y plus y square z cube, where x is equal to rset, y is equal to rs square e power minus t, and z is equal to r square s sine t, find the value of partial u over partial s when r is 2, s is 1, and t is 0. We will apply chain rule to find partial u over partial s. Partial u over partial x into partial x over partial s plus partial u over partial y into partial y over partial s plus partial u over partial z into partial z over partial s. So we start from the first one, partial u over partial x. Differentiate u with respect to x, we will get 4x cube y. Differentiate x with respect to s, will get r e power t. Partial u over partial y will get x4 plus 2yz cube. Partial y over partial s is equal to 2rs e power minus t. Partial u over partial z will get 3y square z square. Partial z over partial s will get r square sine t. Put all these values in the formula, we'll get this equation. Now we have r is equal to 2, s is equal to 1, and t is equal to 0. Put all these three values in x, y, and z. Simplify these. We will have x is equal to 2, y is equal to 2, z is equal to 0. So now we have 6 values, r, s, t, x, y, and z. Put all these 6 values in this equation, simplify these, solve it, we'll get 192 as final answer.
Implicit differentiation dy over dx is equals to minus partial f over partial x over partial f over partial y. Example, find y dash or dy over dx if x cube plus y cube is equal to 6xy. So first shift 6xy to the left side, we'll get x cube plus y cube minus 6xy is equal to 0, which is function of xy. From the formula, we have dy over dx is equal to minus fx over fy. First we find fx, we differentiate f with respect to x, we'll get 3x squared minus 6y. Now differentiate f with respect to y, we'll get 3y squared minus 6x. Put these values here, simplify it, and we'll get minus x square minus 2y over y square minus 2x, which is our final answer. Example, find partial z over partial x and partial z over partial y if x cube plus y cube plus z cube plus 6xy z is equals to 1. So this is an implicit function, a function of several variables. So what we do, we shift one to the left side and we'll get a function in x, y and z. So to find partial z over partial x, it is minus fx over fz. So first fx, which is 3x square plus 6y z, differentiate f with respect to x and then differentiate f with respect to z, simplify it, and this is our final answer. Partial z over partial y is equals to minus fy over fz. So differentiate f with respect to y, we will get 3y square plus 6xz. Differentiate f with respect to z, we will get 3z square plus 6xy. Simplify it and we'll get minus y square plus 2xz over z square plus 2xy as our final answer. Maximum and minimum values. Suppose that the second partial derivatives of f are continuous on a disk with center AB, and suppose that fx AB is equals to 0 and fy at AB is equal to 0 to find the critical point. So we will have d as fxx into fyy at AB minus fxy at AB square. If the value of d is more than 0 and fxx at AB is positive, then fab is a local minimum. B. If d is more than 0 and fxx at AB is less than 0, then fab is a local maximum. C. If d is less than 0, then f at AB is not a local maximum or minimum. We can also use this formula to find d. Find the local maximum and minimum values and saddle points of f of xy is equal to x4 plus y4 minus 4xy plus 1. So we first have to find the critical points. So how to find the critical points? By finding fx and fy. So fx is equal to 4x cube minus 4y. Fy is equal to 4y cube minus 4x by differentiating f with respect to y. Now to find the critical points, we put 4x cube minus 4y is equal to 0 and 4y cube minus 4x is equal to 0. Simplify these two, we will get x cube minus y is equal to 0 and y cube minus x is equal to 0. Now we have two simultaneous equations. We will solve these equations by the method of substitution. From first equation we have y is equal to x cube. We put this value in the second equation. We'll get x power 9 minus x and then take x as a common factor, x into x8 minus 1. Difference of two squares, x4 minus 1, x4 plus 1. Again difference of two squares, x square minus 1, x square plus 1, x4 plus 1. Put it equal to 0 and then we will have the roots of x, which are 0, 1 and minus 1. Put these three values in any of these and we'll get 3 points, 0, 0, 1, 1 and minus 1, minus 1. To find d, we have to find fxx, which is 12x square, fxy, which is minus 4, fyy, which is 12y square. Now, the formula of d is given as this. Put all these values in the formula, we'll get 144 x square y square minus 16. Now for the first point, 0, 0, put 0, 0 in D will get minus 16, which is less than 0, and it is a saddle point. So F has no local maximum or minimum at 0, 0. Now put 1, 1 in D will get 128, which is more than 0. Now put 1, 1 in F, XX will get 12, which is more than 0. So from case A of the test, we put 1, 1 in F, and our answer is minus 1, which is a local minimum. Now for the third point, put minus 1 in D, will get 128, which is more than 0. Now put minus 1 and minus 1 in F, XX will get 12, which is more than 0. Both are positive. We now put minus 1 and minus 1 in F and we'll get minus 1, which is also a local minimum. Recommended reference book or textbook for this course is Calculus Metric Version 8th edition by James Stewart. This is the end of the lesson. Thank you.